Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll use concepts of inverse trigonometry function to solve the problem. As per the problem, find the exact value of tan of inverse of sine of x. This term is made up of the outer function tan and the inner function inverse of sine. The first step is to analyze the inner function inverse of sine. Let's assume inverse of sine x is equal to t. The value of t should be within the range of inverse of sine. The range for inverse of sine is negative pi over 2 to positive pi over 2. So the value of t should be greater than or equal to negative pi over 2 and less than or equal to positive pi over 2. Next, we can move inverse of sine to the left side of the equation with t. I get sine of t is equal to x. Assuming x is a positive value, sine of angle t is equal to positive value. That means the value of angle t should lie between 0 and pi over 2 because angles between 0 and pi over 2 are in quadrant 1 and sine is positive in quadrant 1. Angles between negative pi over 2 and 0 are in quadrant 4 and sine is negative in quadrant 4. So for this analysis, we can assume x is positive, so we can draw angle T in quadrant 1. This is a right angle triangle, that's angle T. We can label the side lengths in this triangle using the formula for sine ratio. The formula for sine is opposite over hypotenuse. We are given that sine of angle T is equal to x. The denominator of x is 1. That means the length of the opposite side is x and the length of the hypotenuse is 1. Now we can find the length of the horizontal side in this triangle using Pythagorean theorem equation. In this equation, C represents the length of the hypotenuse and A and B are the lengths of the other two sides of the right angle triangle. We can sub in A as x and solve for B. Next, we can apply square root to both sides. I get b equals square root 1 minus x squared. The length of the horizontal side is square root of 1 minus x squared. Now we can find the exact value of the given term, tan of inverse of sine of x. Let's assume this term is equal to y. Next, we can do the substitution for inverse of sine of x. We can replace inverse of sine of x with t. So we get tan of angle t. Now we can use the triangle to find tan t using the formula for tan ratio. The formula for tan is opposite over adjacent. For angle t, the length of the opposite side is x and the length of the adjacent side is square root of 1 minus x squared. This is the expression for y, assuming x has a positive value. Therefore, we can conclude that tan of inverse of sine of x is equal to x over 1 minus x squared under the square root, assuming x has a positive value. If x has a negative value, then we'll have to draw the triangle in quadrant 4. That's angle T. For angle T, the length of the opposite side is x and the length of the hypotenuse is 1. We will use Pythagorean theorem equation to find the length of the horizontal side or the adjacent side, and that will be square root of 1 minus x squared. Now we can find the exact value of the given term. Let's assume it's equal to y. We should replace inverse of sine of x with t. We have to find the expression for tan of angle t. In quadrant 4, tan is negative. The formula for tan is opposite over adjacent. So tan t in quadrant 4 will be equal to negative x over square root of 1 minus x squared. This is the expression for y if x is a negative value. Therefore, in quadrant 4, the exact value of tan of inverse of sine of x is equal to negative x over square root of 1 minus x squared. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.